So I guess we'll get started. So welcome everyone to this tutorial on getting started with the computational social science cluster. So my name is Phan. Where's our mouse? Do we have a mouse clicker? Okay, maybe not. Okay. And also Sui Shang Liu will be running most of the tutorial actually, so I should give him credit for most of this, or maybe fault, I don't know which one. So I just want to kind of introduce a little bit about the motivation for the CSS cluster and kind of the idea behind it when we first started this. So the CSS cluster was a school of computing strategic initiative funded by the dean and the provost at NUS to try to promote more social sciences, provide the infrastructure for really the tools to do like large data sets, right? So I think some of that was, so we're calling this cluster the Musang cluster. We'll talk about a little bit where the origins of the name later. But the problem that we're trying to solve here is that what we noticed a lot amongst my colleagues and a lot of our researchers is that we tend to run our own cluster, our own or not even cluster, our own machines and servers, hosting it, and then try to do research on it, and then you have to maintain it, and then maybe it needs maintenance, it needs upgrading, and then we need to add more hardware, and so forth and so forth. So there's a lot of like redundancy in the way that we operate for our research, right? So then the idea behind this cluster is then is just trying to put it all into a centralized place to save everyone a lot of effort, so we can be more efficient, put more resources into larger clusters in this shared, really private cloud. And we will also try to work with some security. And here I have an asterisk on it. It's basically just saying that we'll try to keep as secure as we can, keeping software updated, keeping the system most secure from like hackers and security breaches. But a lot of the way how you use it and the usage in terms of maintaining your agreement with the companies and whatnot is really up to you. Right? So that's not our responsibility. Our responsibility is just more on the technical security level. Okay. So if you are not careful about your own data, that unfortunately is not something that we can work with. Okay. But that's the idea, is that we're trying to, at least at the technical level, provide you some security to host your data sets. So this cluster then, it's a high performance computing platform, HPC. What I also noticed is that around NUS, there really was no HPC service for social scientists. So now that we're starting to see a little bit more, but if you go to that Com Center, NUS IT, they have these clusters, but they're more for engineering. So the software there is for more engineering. There's not as much storage and these solutions for people working in like the IS, business, economics domain. Okay, so that's the motivation for this. So we are providing some storage, software tools, and I would say it's really ideal for medium to large size data sets. So of course, if you have small data sets, that's fine too, right? It's just generally people prefer to just run on their laptops. But once you get into like memory issues, once you start running a lot of CPUs, then you need something that's hosted. Then that's just the place to do it. So that's kind of the idea. Of course, like I said, you can also, if you need a shared space amongst your team members, this is also a place to do it. So you want to have a directory that you can share amongst the whole team, that everyone can work on a different piece. So that's what it's for. Okay. So the workflow and the application process is, we're trying to keep it fairly straightforward. Is that for every PI can register. This does need to be an NUS affiliate. We will eventually move to some sort of yearly subscription model, just to make it sustainable, because we are hiring like headcount to try to maintain the server and do all these services for you. Okay, but Mohan is trying to guarantee it's going to be free for SOC faculty for a lifetime. So we hope that will be so. For now, it's also free for non-SOC faculty, and we'll try to maybe start slowly ease in and transition into a more subscription model. But again, we're just trying to make it sustainable. This is money that otherwise you would have to buy your own servers, spend your own time to maintain. That if you just give us hopefully a smaller fraction of say your research grant, then it will be just a buffet style. You just put in your data set, everyone on your team can use it, and use as much as you like. That's perfectly fine. Right, so that's just really definitely open to business school, econs, and anyone else that's interested in this. So I think that's the model we're trying to move forward in doing so. So once you subscribe, then you'll be assigned a group name for the PI. It'll be a PI project tuple or tuple. So it'll be, so for example, it'll be for me, it'll be a Phan and then underscore some sort of project name. And then under that project name, you can have a group name. You can have a number of collaborators. And really, we try to make it as open as possible. So I would like to say we can open up to non-NUS members as well and all our collaborators. So that's kind of the idea. So they can come in even without an NUS account. They can come in and work on the projects together, right? But again, if you have some data privacy issues, then you keep the data on the server, and then your external collaborators can come in and work on the server without transferring out. So that's kind of the mode. And so all the data then will be in the shared group folder. And so each PI can, of course, have multiple projects, different subsets of collaborators, students, and external collaborators on board. Okay, so that's kind of the overall big picture. So I'll pass over to Shui Song to kind of get started. So just a couple of that thing, just if you just kind of came in, is we asked everyone to register in advance for an account. If you have not, we do have some temporary accounts here to pass out that you can log on right away. And if you're a Windows user, you can install Xshell and XFTP. If you're a Mac user, you can follow along without any extra software installation. I also have a couple of my students here to help out. You can guys raise your hand. So students, my students, not students. Oh, you need, okay. Yeah, so if you also have questions, just raise your hand, and my students here can also kind of sit through you and help you through some of the technical issues, okay? Okay, so take it away. Sorry. So when you register, there's an option to, there's an option asking if you need Wi-Fi. You see the Wi-Fi on. Okay. So if you're not in US, so these are maybe you can share this Wi-Fi. Any extra accounts? Okay. So yeah. So this one also I mentioned. So this tutorial is really this for people who have never done any Linux or any command line. We can cover a bit more of that. I guess I just let you talk about.
Okay, thank you. Thank to Professor for the very detailed introduction. So my sound loud enough? So can you hear clear, right? Or do I use this? It's better. Okay. Okay. This one. Hold on. Just how it works, right? Okay.
Need time to wake up.
Oh, it's working out. No. So probably I just try to speak loudly. Right here. Okay. So thanks for coming. And if you feel something I didn't explain clear, just stop me. So okay. As Tuan said, we want to build this cluster to promoting social science studies and big data analytics. And you may ask why you should use cluster, right, instead of using a personal computer. Especially Wentley's computer has powerful enough hardware to support most of computational jobs. So I want to show you this example. This is a very small proportion of AOS email network. I plotted it for visualization purpose in one of my recent research projects. The blue circles you see is are the email users, and the green lines are the ages between users. So the more the user receives and sends the email, the bigger the node will be. So in this graph, there are 5,000 users, and the number of ages are more than 10,000. And it takes 2.5 hours to plot it on the cluster. So it's very computational, right? And for this time, it's still relatively acceptable. But the problem is, I want to see 10 random such kind of plots and see if there are interesting patterns constantly. So I don't want to wait for 1 day for all these results. So I wrote this very simple script to run the 10 plots in parallel on 10 CPUs. This is a Slurm batch script, which I will introduce later. And it's very simple. The first part is nothing but the specifications of the job. Like the memories you want to use, like the memories, which is 2 GB here, I want to use. And the computing nodes you want to apply. Here is the big memory computing node. And the time I anticipating the job will be finished. So here I overestimated as 5 hours, actually no. And the last line is the files that I want the standard output to be printed in. Then the second part are the actual code that running the plots. The first and the last commands are nothing but load and unload the R software of version 3.4.0. So we use a dynamic environment to manage the user's environment, which I will introduce later. And the third line is the actual command to run the plots. So here srun is the command of Slurm, which is submitted a job in an interactive way. And I applied for 10 CPU cores here, which is N10. And -L is nothing but print the standard output. And this multi-program option means I want to run these scripts in parallel on multiple cores. And finally, this .conf configuration file contains the R script as well as the configurations of correspondence between CPU cores and their jobs. So then within just 3 hours, I got all the plots. And the fastest one takes as much as 2 hours. And the slowest one takes 2 hours and 45 minutes. So I got all these results in more or less the time of plotting one graph, right? And it's only bounded by the slowest job. Okay, so this is just a trivial example. But indeed, with a cluster, you can easily scale your jobs to hundreds or even thousands of cores if necessary, depending on your workload. And also, a cluster will provide with you a bunch of different kind of software tools and modern programming frameworks like Hadoop, Spark, or TensorFlow, and sufficient storage to hold large-scale data sets. And also, it will provide with you different kind of database and data warehouse systems. Okay, so all these things are not possible to be integrated on one single personal computer, right? So that's the reason why it's clustered. Okay, so I will mainly cover 3 sections. In the first part, I will briefly introduce the Musan cluster in a more detailed way. And then I will go for some command lines because the cluster is installed with Linux systems. So I would like to ask how many of you are familiar with Linux shell command lines? Okay, good. So this tutorial might make some sense to you. And in the last part, I will just go through an example of using the cluster. So we had a long discussion for naming the cluster when it was initiated. We have talked about the names of the gods in different mythologies and the famous social scientists in history, or even the names of planets. But we were not satisfied with all of them. And in the finally, I said, why don't we just name it using some fruit name? So there is apple, right? That's blackberry, and that's green plum, which is a database system. So I said, let's call it durian, because we are in Singapore. Then we search durian and Singapore, because durian is anyway just a normal name. So we search it, and Google gives us this. So yeah, you should really try it when you are in Singapore. Then my boss said, okay, let's call it Musa. So then we make the durian meet our data cluster Musa, and we will launch this website soon, which introduce all the specifications of the cluster and the detailed instructions of using all the features of the cluster. And back to itself, the cluster is essentially for big data research, big data analytics, which provide with you large-scale storage and abundance of different softwares to support high-performance data analytics. So in general, it supports any kind of data analytics resulting from any kind of research area. So it's the current appearance of the cluster. It is still in its initial stage. It's very tiny, right? But it has already contained one access node where you can access the cluster, and 4 computing nodes, normal computing nodes, and 2 high-performance computing nodes. And it already has 144 cores with 200 terabyte storage. And it has already supported the most frequently used data analytics softwares like R, Python, and SQL. And very soon in next phase, it will scale to a row of racks, which will contain a few access nodes, which used for balanced login, and about 100 normal computing nodes, and 10 HPC computing nodes. And the cores will be scaled to 2,000. And we will provide several petabyte storage. Also support for Hadoop, Spark, these modern programming frameworks. So essentially, Musa is built using the master-slave architecture. So on top of all the nodes, there is an access node, which controls the entire system. And from this access node, you can observe the status of all the computing nodes. You can manage and write your scripts and submit it to the system to get resource allocation and run your job. Then on the back-end side, currently there are 4 computing nodes and 2 high-performance computing nodes dedicated for data analytics. And at the bottom, there is a shared storage, which provide all the data analytics services and hold large-scale data sets, and can be accessed by all the computing nodes. But you don't have to know anything about them. All you need to know is to talk with the access node. You just manage your scripts there, manage your file there, and submit your job there. So the access node will do everything for your job running. Okay, so let's see how we can access it. So basically, you issue a SSH connection to the server by give the username and the host name of the cluster, which is musa01.01conf.us.edu.sg. And basically, there are 2 ways to connect. The first one is using command lines in some shell interface. So this is X shell I will introduce later. And later we'll see detailed example. And the second way is if the shell interface gives you some GUI interface, that is perfect. You can just put the detailed parameters into the interface. Then just click the connect. Then the connection will be established. Okay, so then in this second part, I will go through some basic Linux command lines. Maybe next step. It's okay. Yeah, that's few. Okay. So I want to go to the basics of Linux systems. All you need to know is that Linux system is a operating system provide very stable services. So that's why most of the services today using Linux as their primary system. So you may ask, what is shell? So you may often hear about it. According to Wikipedia, it's primarily a UI for access the operating system services. So that means shell accepts user input and pass it to the system, then the system gives you back the results. So according to this definition, the desktop environment in Windows is basically shell. You click on the icons and see the results. And also the RStudio is also shell. You issue the R command as input and get the results as output. Then today I want to talk about this Linux shell, where you type Linux commands and talk to the Linux system directly. So there are many popular shell interfaces on the different operating systems. Under Windows, there's PuTTY and Xshell. Both of them are free. And shell is basically my personal favorite. And in Unix-like systems like Mac and Linux, there is built-in terminal, which can provide the SSH function. So all the examples in this tutorial will be based on Xshell 5, except very few which are on the Mac OS. So let's see how we can connect to it. So our Xshell 5, I hope you have installed. Then in the left top corner, you'll have this new dialog. Then here, you can enter, give it a name, and the protocol is SSH, right? And in the host, you just provide the host address. Then the port number is default 22 for SSH, and I will give it a description. Then in the authentication tab, you just give username, and here my name is Xuesong03, and leave the password. Okay, leave the password blank. Okay, then it appears in your session list. Just click on it and connect. Provide your password here. And it will ask you to provide the verification code. I will choose later. So it's basically two-factor authenticator. Okay, here we go. So this is the, so next time, you just need to click on open. Then there's all the session list you have. And click on Musan, you will connect it. Okay, so to ensure the extra safety, we implement this two-factor authenticator. So basically, each time you log into the system, before you log in, you need to provide a verification code, which can be generated using this Google Authenticator or the VIP access. You can download from App Store or Google Play Store. So this is a screenshot of Google Authenticator. It's associated with your account when you scan it. And this 6-digit verification code is refreshed every 30 seconds. And it can be only used once. That means if your current login failed, you have to wait 30 seconds for the next one in order to log in. Okay, let's come to the Linux commands. So before that, I would like to introduce this very helpful website. It introduces basic Linux commands and then introduces the details behind the command lines. And finally, tells you how to write the Linux shell scripts. So you are really recommended to go through it if you are interested in working with Linux systems. So the first set of command lines is about navigation in the system. Let's first see the file systems. So in Linux, there is a root directory, which is the parent of all the directories. And under this, you can see there is a lot of different folders. there is a lib folder which contains all the libraries we use to build and run executables. And all the executables are put in bin or another one sbin. But you don't have to know about this. So almost the only thing you want to know is the NAS folder. It stands for network attached storage. That is because your home directory is under this folder, which is /nas/home01 or 02, depends on your account. And my home is under this path. And also there is a project directory which was introduced by Tuan. If you are involved in some projects. So you might want to know where you are on the system currently, right? So the command pwd will do this, stand for print your working directory. For example, now I print it. I found I'm on the root directory, right? By the way, you can try it almost now if you have logged in. And I change the directory, and again, it's in my home directory, right? And these two commands I will introduce later. Yes.
So if you can log in, if you have any issues, just let us know. We're here to help. You couldn't log in, now try again. So for the temporary accounts, do they have the two FA?
No, don't have. Yes, for the temporary accounts, you just need to put your username, password. Yeah.
That's why you have external computers. So, okay, so I think we prefer the time version. But I guess if you're going to be CI, then that's not. If we don't get the CI, everyone all right? Feel free to stop us anytime, and then we have a team of people here as well. SSH from that.
Yes. Yes, there. So it's the same as Excel, right? So. Okay, shall I continue? Okay. So my experience is if you have problem with login, okay. So most probably your verification code is expired, something like that. Okay, once you log in, you are in your home directory. You can try type this pwd to check.
So if you created an account beforehand, you need to add the mobile app to get this directory. That's in the email. But if you need it right now, we just use temporary account how you fix the problem. Does not require to affect. Sending an email. It's also on on the website. There's a email address. Yes,
Okay, have you all logged in? So I shall continue. Okay. So you might have already seen how I use this ls command. It's basically for listing the files in your directory. For example, it's in the WESST project folder. It has 2 files here. And I changed directory to my home directory. It has such files. And you can use the command with options. All the commands has options. For example, this ls has this -l option where you can list all the details of the files, like the permissions, the owners, the creation time. Okay, we can just view it again. And currently in your home directory, there is nothing you can view. But later we'll go through some examples. So next, you might want to change your directory as I did in the animation. So it's just you just need to issue the cd command and followed by the path of directory you want to go to. It will change it to this project directory WESST. And cd/ it will go to the parent directory, the root directory, and you can else check if you have going to it. Okay. So this is using cd with the absolute path. Another way of using it is to use it with the relative path. For example, I'm now have these 2 folders, packages and projects in this directory. Then just need to cd projects. You will go to it without necessary of enter the whole path. And with cd 2 dots, you can go to the parent directory. Yeah, so currently with your account, you can change directory between your home directory and the project directory. Okay, one thing I didn't mention is that here you have your home directory and project directory, right? However, to relieve the traffic of network, we use the automatic way to mount your folders. That means you have to explicitly write this path in order to mount your directory. For home directory, it's okay because once you log in, you are in it. And for the project directory, initially you cannot view it. So you need to, for example, if you are involved in this WESST project, you just ls this full path or cd to it, then it will be mounted. And if you happen to type the wrong path, you will get stuck. But don't worry, just after a few seconds, it will be reactivated again. Okay, let's go through it again probably. Use pwd to view your current working path, and cd to change your directories, and ls to view the files in your directory. Of course, I didn't mention is you can use ls followed by the path name. Then you can directly see the files in that path without having to change to it. So as with -L, you can see the details of the files. Left side are the permissions, then the owners and the groups, and the date of last modification. You might see I use clear to clear the output on the stand output. Okay, I will be continuing. Okay, this is CD to the radical path. Once you are under some path already, and particular use of CD is just type CD without any path that will give direct you back to your home directory. So this is a simple way to go back to a home. Okay, I will continue to introduce this second set of commands which manipulate the files. So the first one is CP. You might want to copy the files different places. So CP does this. You can just issue, for example, I have this a.txt file in the current directory. So it has this hello WESST workshop inside. I just copy the a.txt to b.txt, then b.txt is there, and it's the same as a.txt. You just copy the source file to the target file. Okay, this is to copy the file, a single file. Of course, you can also copy the entire directory. For example, I have this documents folder. I just use copy with option -R to copy the entire folder. I copied it to documents1. Then it has exactly the same files as the document folder. Right? Okay. So actually, you just need to get some intuition of it. Later, we will go through examples. And then you might want to move your files between different folders or rename it, right? So this is done by move. I want to move this a.txt to the documents folder. This can be done by move a.txt to this folder. Very simple, right? So now A is moved to that folder. We have two under the documents folder. Okay. Okay, with move, you can also rename a file. So for example, I have this documents2 folder. I rename it to documents1. Then you will see documents2 disappears and documents1 there. So this is the way you move the folder. At the same time, you just rename it. Okay, but you need to take careful of this command because, for example, I have these two files. If you happen to rename a.txt to b.txt, which is already exists, then a.txt is gone, and also the b.txt is actually the original a.txt. You cannot get the original b.txt back, so you need to take care of the command. It's like you just remove the b.txt and only keep a copy of the a.txt, right? So always take care of your target file name when you use the move command. Okay, so this one might probably most dangerous command in Linux system. It removes a file. So for example, I remove this a.txt, then it disappears. And I also can also remove the entire folder by issue the -r option. Just issue the rm command followed by the file you want to remove or the folder you want to remove. So I said it's dangerous because once you delete something with it, it's gone forever. It's not like in Windows you have a recycle bin, you can recycle the files. On Linux, it's just deleted forever. So I really had some very awful experience. I wrote like 1,000 lines of code, then happened type remove this folder, the entire folder. Okay, then you want to might make some create new directories in your home directory. So this is done by make dir command. You can now try to create some folders in your home directory. For example, I make dir documents1, then there will be a new folder under your directory. You can try it in your home. And also we can make a subdirectory inside directory. So with this command, I create a subdirectory, subfolder document2 inside this folder document1. Okay, so actually with the Linux system, you can find the mysteries behind the command yourself. Use commands like which. For example, this command can determine where the command is located, like which CD is under the user bin, which is the default user executable folders, and also the make_dir is also inside it. And this command make_fs, which make the file systems, is in some sensitive folders. And the particular use of this command is you can check whether a software has been installed on the system, like which person it has been installed here, and R is not installed currently. Very simple, right? So this just gives you very general information of the software, if it exists or not. Next, you can issue command with the option help to see the detailed usage of this command. It will show you the syntax and the options, all the options of the command. For example, CD, okay, unfortunately it does have. So not all the command have it, but most of them have. Then ALS, it have detailed instructions with options and explanation of the option. Give you more specific result output on the screen. Also, you can check the manual, user manual of the command. We just issue man and the command. It will show the entire documentation of the command, which is similar to the help manual, but it's more detailed. Okay, so let's try to read some files. So you can use this cat command to read the files. It mean the command itself means concatenate, because it was used to contents of different files. But of course, you can use it to view the content of the file. So for example, I want to read file a.txt. It has just one line of text, and in b.txt, it has 10 lines, right? Okay, so how if the file is too big to view entirely? Then we have this command to just view the first and the last parts of a file. So for example, you issue head -2.txt, it gives you first 2 lines, or you view the first 3 lines, and tail the usage is the same. It shows you the last 2 lines of the document, right? Just use dash followed by the number of rows you want to view. And you can also use grep to filter the content of a file. So basically, it's used to match the specific stream or regular expression. For example, you grab 9 in b.txt, it just returns you this line, and the 9 is searched and highlighted, right? Then if you grab WESST, it will return you all the lines, because each line contains this keyword. Okay. So then this Linux system, Linux shell provide a very powerful command, which is pipelines, where you can trace different commands together, which means you use the output of the former command as the input of the latter command. Then use this combination to achieve very specific text processing. For example, I use this head and tail. I take the first 5 lines, and from it, I take the last 2. So you can imagine what we will return, right? So it returns the 4th and 5th line. It's very powerful when you want to, very useful when you want to view the middle part of a file. And also I can chain another command, grep5, it returns you this one. So basically you can chain any command that has output and input. For example, I chain ls -l with grep b, right? Then it just returns me this folder, this file with the detailed information. This is pretty useful when there are many files in one folder and you just want to view if a particular file is existing or not. Right, so the pipeline, you just use this vertical line to chain the command. Okay, then you might want to edit your files, right? So now it's your home directory is empty, but you can use this command to create a file and edit something. You can try to nano. Sorry, okay. The GIF, so it's just going on a loop. So just nano followed by the file name. You can open a text editor, and you can just edit like the txt on Windows, and it has on the button shows you the options. You can save it or exit or copy or paste with this command. So the arrow before the arrow before these characters stand for the control. So you use Control X to exit, Control O to write out to save to disk. I add this one line and save it as still the original name, a.txt. Okay, I have it already. But sometimes you might want to edit your files locally and upload it to the server, or you want to download some results from the server to local for viewing. So SCP will do this. So basically, you can issue this command line. Like, for example, I now have these two folders, files in this folder. I want to put it locally in my Musan files on desktop. So I type SCP, the source file, which is on the server. So I use username at the host name, and there's a semicolon between the host name and the file, the path of the file. And this is the target, the destination folder. It is on my local desktop, desk/Musan files. And you need to provide a password for this SCP. Okay, then it's done. You can check it's in your file already, right? So you might also want to upload files to the server, right? For example, I have this c.txt in my local machine, which is on the desktop Musan files. Then I want to upload it to the server. So basically the same way, but you just reverse the order of the two parts. So first, this is the destination file in your local machine, the source file in local machine, and the destination becomes the Musan path, right? And you also need to provide your password. And that's it. Okay, so it's in your folder now, right? And of course, if the share interface provide you with some GUI, you can just use it. For example, under X-share, you click on this FTP dialog, right? Access FTP dialog. Then you can have a graphic interface to transfer files in and out. Right, left-hand side is my local machine, and right-hand side is my home directory on Musan. So it's very easy to use this graphic user interface, right? Just drag it to your local machine and to server. Okay, so yeah, I just covered these basic Linux shell commands. Seems a lot, right? But with these basic ones, I mean, 99% of the time you will just use this kind of commands. That covers most of your work. And of course, if you want to learn more, you can try to learn these advanced commands, like screen to run the program in background, and less sort unique to manipulate the files. And this awk is a particularly powerful text processing tools, which provide you provide you very easy ways to read and process large-scale files. And finally, this VM is my preferred text editor, which is more powerful, but a little bit difficult to use. But of course, if you can go through this website, then you will definitely become an expert of Linux shell command. Okay, so I use the last 30 minutes to go through example to using Musen. So before that, I first introduced this module called module environment. Basically, we use this to manage user environment dynamically, which means you use your tool, you load your tool when you use it. So this is particularly useful when because different users may have preference to different softwares, right? And may switch between the software of different versions just because some packages are only available in specific versions, right? So it's very easy. You just type. So now there is no R, right? I type module load available to check what kind of softwares are available currently. And I see these versions of tools. And I load module load R / 3.4.0. So now I can use R, right? The version is correct. And once you are done, you just type module unload R / this version number to unload it. So now R is gone. Very simple, right? So this is particularly useful when you want to switch R of different versions. So we will install or continue to install more and more softwares, which will be available soon. Okay. The second concept is Slurm. So we use Slurm for centralized job scheduling and resource allocation. Basically, on access node, you just submit your Slurm batch and acquire the resources to run your programs. The most frequently used commands like sbatch, which used for submit your job, sq to check the status of your running jobs, and s account to check all your jobs, including those have been finished, and sinfo to check the status of the computing nodes, to check which computing nodes are currently available. And here is a tutorial, very detailed tutorial of Slurm. If you have time, you can go through it. But these 4 commands are the most frequently used commands. And this is a sample of Slurm batch you will submit for running the jobs. As I said, the first part are the parameters of this batch. For example, the first line, you give it a name. And the second line, you want what kind of information to send to your email. And third line, you provide your email address, which will affirm the information about the job, whether it's complete or failed, or begin or ended. And third line, untasks, so the meaning of untask is how many tasks you want to perform on a CPU. If you show 1, that means I want to run 1 task on each CPU. So which in turn means you just need 1 CPU, right? And I want to use the general computing node. So our Musen currently have 4 kinds of partitions. Also means 4 kinds of computing nodes: the general computing nodes, interactive computing nodes, and big memory computing nodes, and what is the other one? And the first one I don't remember now, but you can check with sinfo. And they have different usage with different kind of time limit for maximum length of a job. And I want to apply for memory size of 100 megabytes and the running time 20 minutes. And last line is the output, is the files where you want the standard output to be printed in, like the error logs and the things printed out by the system on the screen. And the second part are the command. Here I use Python as an example. You load the Python module, right? The second line is nothing but just type something on the to print something on the screen. And I run this script here. Test py is my Python script. And finally, after it's done, you just unload it, right? Then you just submit it using sbatch test.sh. This is the name of this batch script. Then it will be submitted to the backend side and get the resources to computing. Okay, so thanks for your attention. We'll just go to some examples to show how to use Musan. I will use XL5. Okay, there's nothing currently. I create a new one. I will use my username. Okay, connect to it. You can accept this key is used for identification. You can connect, accept it. Next time, it will not be prompted. Okay. You can change the font size here. I'm going to use larger one. Okay. So you can go to the project folder I created for this workshop, which is S project 01 WESST. Inside it, you will see, okay, who created this document one. So we have this, we have this data which contains data I will use later, and the SS folder contains some scripts. Let's see what is inside data. We have two. So the email, the student.csv contains the student information. For example, has this first 5 lines of student.csv. It feels like the student ID, his sex, his race, right? And countries, programs, faculty, such as CPA, right? And from the second line are the detailed values. Each record stands for one student. For example, these students are Chinese, in Singapore. Okay, so this is a synthetic data set, so probably not realistic. Never mind. And he has a relatively high CPA. Okay, and in email file, so basically it tells you the senders, the recipients, and when the email were received, and the subject of the email, right? So this is the sender, the recipient, and the time the email was received, and the subject, right? So now we try to do something on the data. So first let's check what is inside the source file. We have this 6 files, right? So 3 of them are the R scripts, and the 3 of them are the batch scripts, and 1 of them is the configuration for run the programs in parallel. We can first check, you can check this student. Sorry. So it basically read the student CSV and calculate the mean CAP, mean GPA, and find the best student, the CAP of best students, and finally just do a summary of the distinct races. I want to open another one. With Excel, you can open as many dialogue as you want. Okay, run verification code. Okay, so it's in my home directory, right? So now there is no R, right? I type module load. It's available now. So now I'm going to R. And let's see what are the commands doing. The first one, you can try to do it on your local machine. Here, you can use this function paste and it read the student file. By the way, DF is a structured data frame, which is very popular in R. And you can use this one to print, to calculate the mean CPAs of all the students. So this is data frame, this is the CAP column, and this command is to remove the values that is not a number. So sometimes your data is not very clean, right? You want to remove those values which is not a CAP. And I got this average, right? Very simple. And I want to print the distinct races with their numbers here. Right? It gives you a summary. Very easy to use. We have 7 groups of races, and each group of so many students. Okay, so this is how to use the command line. But with Musan, what you want to do is to run jobs in batch, right? So let's see how we do it. I'm now in my home directory, and let's copy the source to your home directory. I first copy this student R, my home. So with your home, you can you can use save with dash. It means your home directory. Okay, it's there. And we want to submit as a batch. So I also copy this. I have this batch script, and you need to modify it a little bit. Big. Right. So job name I don't want to change, and I want all kinds of email types. The email names, the email address is okay. Number of cores, I just need 1 core, and I want to use this general partition. The thing you want to change is this one. So you need to write it to your home directory where you can write, right? So for me, this account is on the home 02, the zone 04. This is my home directory, and this is the name of the files that the output will print to. And this one is stands for the job number. That's to distinguish between the same kind of job of different batches, right? And then I load the first line, load the R module, and the second line I run it as a script. Just type R script R file. Here also you change my directory to my home, right? And after it, I just unload. That's it. So by the way, I'm using VM. You can use Nano, do the same, no problem. Sorry. But there is no highlighted words. Okay, so I will. That's it. Now, let's first check the information of the nodes. We have 3 general computing nodes from comp 02 to 04, right? And 1 unrestricted node, which is comp 01, 1 interactive node, and 1 big memory node. So this column shows the time limit that the maximum time a job is allowed to run on this node. For general partition, you can use it for 7 days, no problem. For interactive, you can run 1 job for 3 days. For this unrestricted, there is no time limit, but probably many people are running jobs there. So probably there will be a long queue. Also has the 7 days for maximum time limit. So this big memory has a much bigger memory than the usual computing nodes. And let's try to submit it. Now we have these two, right? We submit student message. It will give you output. You have submitted as job ID 219. So because this has done very quickly, just in less than 1 second, you cannot see it in SQ, but you can check it use as account, right? I have written before. And this one, right, is your job, which has been completed. And let's check the output. Okay, this is standard output file. And inside it, you can see the commands we run as scripts, right? So these 4 commands for the means, maximum, mean, and the distinct races, right? All out here. Quite simple, right? Okay, next, let's try to see another one. We copy another source file, email.r, to my local, and also the batch file. So in this email.r, I do nothing but with it and print the dimension of the data file, right? So it tells you how many rows inside the file and how many columns in the file. And this one here, I use argument where you can pass your argument to the R script, which is a more dynamic way to run the scripts, right? So try to first run it with srun. Srun is a Slurm command which you can run it in an interactive way. I want to use just 1 CPU core. And I want to run it as R script. So I use R script. Okay, so there is the, sorry, I didn't give it the argument. So I want to read the first 1,000 rows inside the file, right? Okay, give the output. It has, I have read 1,000 rows, and each row has 4 columns. So next, let's try to plot this email file, like I did in the beginning of my presentation, right? The figure. I will copy this plot.r to my home, and the batch script and the configuration file, right? Let's see what is inside. So this R script basically read the first argument 1 rows of this email file, right? And they use the first 2 columns as the nodes. And this summary is just summary the graphs we have read. And I give it a name, so you can use this paste to concatenate multiple strings together to form a file name where you can output. I use this because we have an argument, right, which stands for the number of rows I read from the file. And I want to output the plot as PNG. And here, the data file is okay, don't have to change. But here, I want to change it to my home directory, right? And this one is the actual plot command, which plot this graph G I read were constructed by the first, for example, 1,000 rows of the email file. And the layout is the layout of the plot you want. Here, I want to plot it as a sphere. And I don't want the vertex label. And one to the vertex size is proportional to the degree of the vertex. And the each arrow size, because it's a directed graph. And the each frame color, the vertex frame color, as well as the vertex color, both of them are blue. And the each width, and the each color, right? And this dev.off basically output the plot to a file. Okay, I've changed it. So this computation file is nothing but I want to run 3 plots in parallel on 3 CPU cores. So this is a number you name the job because you apply for 3 CPUs. It has to be started from 0, then 0, 1, 2, and run R script. And my script now it is in my home directory. Right. This is R script, and I give each one a parameter I pass to the R script, which is, for example, this one I read the first 1,000 rows, and the first 1,500, first 200, 2,000. Then I can run them in parallel. Check this run bash. Right. Here it's still the same. I just need to change the output location. And use srun to apply for 3 nodes and run as multiple programs with this configuration file. Okay. I just submit it as a patch. Shows the big memory partition, right? Okay, it's complete. Right. The 3 plots are there. So now I want to download them to local. I use this XFTP. Provide my password. And the verification code. So these 3 in my home, right? I put it on desktop. So they're there, right? The first one, 1,000 node, like this. And 1,500, more denser, much denser, and 1,000, right? And you can check. Okay, just now we didn't check the status of node. Once submit, the node you applied will become allocate or running something. Right now they are all idle. So that's it for the example. And I hope you know how to use it. Musan, if you still have question, you can talk to me. No problem. Thank you very much.